In the previous part of the video, we saw that 1 mole of something is nothing but 6.022 times 10 raised to 23 particles. It could be atom or molecule or anything. If I give you 1 mole of pure gold, then what will be the number of atoms in it equal to? Yes, these many atoms. And 1 mole of pure water will have these many molecules. But what is the scientific definition of a mole? Scientifically, 1 mole is defined as the amount of substance that contains the same number of atom, molecule or particles as there are atoms in 12 gram of carbon-12. Yes, even I didn't understand it when we read it for the first time. Let me break it down for you. Let's remove this definition from the screen. What we have on the screen now? 12 gram of carbon-12. Carbon-12 is one of the isotope of carbon. Now 12 gram of carbon-12 is what was taken as standard. What's so special about this? Can you guess the number of atom here? Yes, it's 6.022 times 10 raised to 23 atoms. Now that you have understand this, let me repeat the definition for you. 1 mole is defined as the amount of substance that contains the same number of atom, molecule or particles as there in atom 12 gram of carbon-12. Did you understand the definition now? It consists of two simple parts actually. It tells us that this part is equal to this part. The number of particles in 1 mole of a substance is equal to the number of atoms in 12 gram of carbon-12. That's all the definition tells us. Many people get confused when it comes to the concept of mole. Let's take many more examples to be absolutely sure. About taking the same example of pure gold and pure water. When we say 1 mole of pure gold, then according to our definition, it will have the same number of atoms as the number of atoms in 12 gram of carbon-12. That means 1 mole of gold will have 6.022 times 10 raised to 23 atoms of gold. Similarly, water will have the same number of molecules as the number of atoms in 12 gram of carbon-12. That means it will have 6.022 times 10 raised to 23 molecules of water. Remember, the definition uses carbon-12 as a standard. It is used to compare the number of atom or molecule or particle present in the substance. But what's the mystery behind this number? A scientist named Lorenzo Romano Amido Carlo Avogadro came up with this concept. I know the name is long, so we will address him as Avogadro. So the number 6.022 times 10 raised to 23 is called Avogadro's number. It's just the number used to represent quantities. It's similar to how we use the word pair for 2 or the word dozen to represent 12. Similarly, Avogadro's number is the term used to represent 6.022 times 10 raised to 23 number of any entity. So can we go to a shop and say I want Avogadro's number of chocolate? Of course we can. The only problem is that the shop wouldn't really have those number of chocolates and neither we will able to carry them back home. So getting back to the concept, Avogadro's number is just another number used to represent quantities. But the number is so huge that using this in daily life is not practically possible or advisable. Then why does the number exist if we don't use it? Yes, the number is not commonly used in daily life by us. However, it comes to the rescue of chemists that work with atoms, molecules or electrons and many such small entities. That is the reason why it is used to calculate 1 mole of any substance. Let's talk about the last concept. We know that 1 mole of carbon-12 is 12 gram of carbon-12. That's because 12 gram of carbon-12 has the Avogadro's number of atoms. Now let me ask you a question. If you answer this correctly, it means you have understand the concept of mole. What will be the mass of 1 mole of pure gold? Will it be 12 gram? The answer is no, it will be not 12 gram. Note that in both the cases the number of atoms is same, but the mass of an atom of gold is different from the mass of an atom of carbon-12. Hence, the mass of 1 mole of gold is definitely be different from the mass of 1 mole of carbon-12. So 1 mole of gold weighs around 196.97 gram. That is because mass of gold is different from the mass of carbon 12 atom. Similarly, 1 mole of water will have the Avogadro's number of molecule, but it will not weigh 12 gram. So, if we take 1 mole of water and find its mass, we will get the answer 18.015 gram of water. And I am sure you know why. For the sake of comparison, if we take 1 mole of gold, 1 mole of silver and 1 mole of copper, then all of them will have the same number of atoms in them. That is 6.022 times 10 raised to 23 atoms. This is the number of Avogadro's number. However, the mass of each one will be different. That's because the mass of individual atom that make up this element is different.